Section 3.5, Example 3. This is the logistic growth model. It's given by either f of t or a equals c over the quantity 1 plus a times e raised to the negative bt power, where a, b, and c are constants. C has to be greater than 0 and b has to be greater than 0. And something else to know, c is what's called the limiting size of f of t. Okay? Example 3 states, in a learning theory project, psychologists discovered that f of t equals 0.8 divided by the quantity 1 plus e raised to the negative 0.2 t power. It's a model for describing the proportion of correct responses f of t after t learning trials. Find the proportion of correct responses prior to learning trials taking place. Okay, well, if t is the number of learning trials prior to the trials taking place, means that t equals 0. So we'll say f of 0 equals 0.8 over 1 plus e raised to the negative 0.2 times 0 power. Okay, well, this is going to end up being e raised to the 0 power, and remember, that equals 1. In fact, anything raised to the 0 power, with the exception of 0, equals 1. So this will equal 0.8 over 1 plus 1 is 2. And so when we do the division there, the proportion of correct responses prior to the learning trials taking place is 0.4. Next, we're asked to find the proportion of correct responses after 10 learning trials. So t is 10. F of 10 equals 0.8 over 1 plus e raised to the negative 0.2 times 10. And that equals 0.8 over 1 plus e raised to the negative second power. And now you just need to evaluate this on your calculator, and you should get 0.7. So the proportion of correct responses after 10 learning trials is 0.7. Next, we're asked, what is the limiting size of f of t? Remember, if you have f of t, in this case it's 0.8 over 1 plus e raised to the negative 0.2 t. The limiting size is whatever c is, and c will be right here in the numerator. So the limiting size of the function is 0.8.